Greetings Earthlings, welcome to another episode of Car Tech, and today we're going to be talking about the silent killer in our cars, at least many of our cars. And based on the video frame shot, I'm sure you can guess what that is. And yes, that is aftermarket floor mats. Now, this is a typical instance of a vehicle that has one installed, and I did not make any changes. This vehicle came into the shop and we're just using it as a case study. So, first things first, I would like to first show you what the factory mat looks like. So I'll get this guy out of the way so that you can see what we're talking about. So clearly there's an outline for the dead pedal or the footrest on the left. Then there's a clear demarcation to allow the throttle pedal move freely without any obstruction. And for most mats, you will also find that to the rear of the mat, there's either an anchor or a hook that holds it and prevents it from moving forward as you drive, because the action of your feet will always almost want to push the mat forward. Now, come in and take a cleanliness conscious driver or vehicle operator, and they will innocently add this mat. Usually it is incorrectly sized. As you can see, this one is moving all over the place. It is not tethered. There's no hole or anchor for it, and it does not give any allowance for the throttle. So, as you drive along and operate the vehicle, it tends to slide up. How high up will depend on a few things. For some mats, they will have teeth or some tiny hooks on the underside that help it grip onto the fabric of the factory mat or the fabric of the carpet. Yeah, this is a good instance. See? Even the factory mat has those tethering teeth. So you have those, and that sort of helps keep the mat in place. But this video today is just to make us aware of the danger that we are all exposed to when we do this. And I have diagnostics plugged in. I will show some data as we do the video, just for you to see what is happening when these mats are put into use by people who may not understand exactly what they do. So just let's set up, shall we? So in this particular instance, I will only enable certain parameters, and in this case we have sensor 1 and sensor 2 on the accelerator, which is the pedal here, and then we also have throttle sensor 1 and sensor 2. The rest are just for, shall I say, analysis later. But yes, this particular car doesn't give percentage readings, so we'll go with the voltage readings. And for anyone who knows a little math, you'll be able to see what is happening here. So at idle, with no pressure or force on the pedal, you will have the voltage reading at about 0.76 or 77. There's some discrepancy between the two sensor readings because it's for comparative analysis for the engine computer to figure out exactly what's going on. So that aside, let's just take a practical example. You've put in your mat, you've driven around, it's ridden behind your pedal. So now as I actuate the pedal all the way to what appears to be full throttle, look at the voltage. That is going to be about 3.8. So again, 0.7 for idle, and full actuation with the mat in place will just be barely 3.8. Now there's a whole chart with the calculations on what each voltage reading means, and that is what the engine computer uses to determine whether or not you're at full throttle. So let's move the mat out of the way and then try again. Now watch. 0% throttle, 100% throttle. See, we are now at 4.4 volts. That means you have a discrepancy of, I'm not good at head math, so I'll put this somewhere on the screen. But yes, that is the difference between having the mat in the way and the vehicle seeing full throttle versus not having it in the way. So let's just do another practical take. Mat in the way, 3.8. Mat out of the way, which is the way it's supposed to be, 4.4. I'll explain why that is important a little later on, but let's go with other instances of other vehicles and see exactly what this means. Okay, second vehicle case scenario. This time we actually have two mats. One clear, one rubber at the bottom on top of the factory mat, which is a nice carpety feel. So we have plugged in diagnostics. Let's see what we get, shall we? Throttle off. Get about 7%, which is normal. I'll explain that a little later. Full throttle. We only get about 56% of throttle. Back to 7%. Let's pull out the maths, shall we? And you see the line that the manufacturers keep very wary of. Let's try again, shall we? So, sorry for the glare. Okay, with no mats in the way, we're at 7% off throttle, and look at that, 83% full throttle. So, like I was trying to explain earlier, what the numbers mean is that manufacturers usually consider anything below 10% as closed throttle, and anything above 80% for some vehicles, and for others 85% as full throttle. So it is somewhat acceptable for you to have a little digression in the values, but the thing is, you saw the difference. With the mat in the way, the engine computer will not be getting the data it needs to give you full power. Okay, case scenario number 3. And just as a side note, all these vehicles we're reviewing have not been tampered with. This is how they came into the shop. We have only plugged in diagnostics to read this particular information during this video. So in this case, you can see you have a slightly different design. It's some sort of a bucket mat, and it's in what feels like hard plastic. It's not rubber, it's more plasticky. Yes, so again, diagnostics has been plugged in, so we are looking at throttle position sensor, and we are at 9% on idle. So let's try full throttle with the mat in place. I am getting just about 54%. Mat out of the way. Let's just pull it back. And again, you will notice there is always that manufacturer leeway for the throttle. So let's get diagnostics back, and now full throttle, 82%. So I think we are all in agreement that the 3 vehicles we have reviewed all have the same illness and ailment. So we shall talk about what we can do and how to be safe. To find out why this mat issue is a bit of a safety concern, I'd like to share some diagrammatic expressions here. Maybe that'll help with understanding what actually happens. And before we can get to that, there's 2 main throttle types as they are commonly known in the industry. There is drive or fly by cable, and there is drive or fly by wire. The main difference here is one is a physical setup, while the other one is an electronic setup. Allow me to explain. But before that, I'd also want to bring to your attention that there are 2 main types of throttle pedal. So you will allow my artistic self to help explaining the 2 main differences. One difference between these 2 guys is where they are hinged and how they are designed. So let us call this number 1 and number 2. Now on number 1, we have the pedal, let's call it roof mounted or ceiling mounted, and on number 2 we have it as floor mounted. Difference here is just where the hinge is located, as you can see. So as the driver actuates the pedal, they will respond differently. This one will be more of that way, while this one will be more of this way. So this is the more common type, but this also has its applications in certain vehicles. So now that we know the two main types of throttle pedal, let's see how they work. And let us start with a fly-by-cable setup, right? So there are some main components that are common between the two, and I shall use them in these expressions. One is a throttle body, the other is a throttle pedal. And in this case, let's just take the ceiling mounted throttle as our throttle pedal type. Okay, so in the fly-by cable, we have a physical cable that links the throttle pedal to the throttle body. Throttle body is in the engine, while the throttle pedal is in the cabin with the driver. In most setups, especially if your vehicle is electronically injected, you will have some additional component here called a TPS, throttle position sensor. This guy sends his information to the ECM, which is a engine control module. So in as much as there's a physical link between the pedal and the throttle body, the engine is still aware about what you're doing. So when you demand for 100% throttle, in as much as the throttle body will be open at 100%, the engine can still determine how much of that power you actually get. It's not as efficient, but it still works because it is based on select things, and I will describe those in the next explanation. So that's fly-by cable. Fly-by-wire, which is a more common throttle type, is actually quite efficient. So again, you have the two commonalities, which is your throttle body and you have your throttle pedal. In this case, let's also make it ceiling mounted. And the only difference here is that the ECM or the PCM, powertrain control module, will sit in between the two guys. So when the driver demands for, let's just say, 60% power, it is not transferred directly to the throttle body like that for two reasons. One, it's intercepted by the PCM, so the PCM needs to determine a few things before it sends that signal to the throttle body to open up. And these are inclusive of, but not limited to, things like your intake air temperature, your coolant temperature, your vehicle speed, your engine load, ignition timing, etc, etc. So the PCM decides when it should give you the requested power demanded by the driver and pass that on to the throttle body. A good instance might be, in this case, it is a cold morning, very, very cold morning with ambient temperatures of, let's say, sub-zero, right? So you just started the car, you want to get on the road and hit your maximum speed and power. So when you demand for 100% throttle, in as much as you're asking for that, the PCM will check and say, hey, it is very cold outside, so my intake temps are nice and cool, but my coolant temp is not yet ready, so I will not give you 100%. Why don't you instead take 40% power? And as the variables keep changing, the PCM will then adjust this on the fly. This is the main reason why sometimes you will have certain vehicles behaving very erratically when the ambient conditions change, especially when it is hot or exceedingly cold. And this is the reason behind why it does that. Now, if you were to have a fly-by cable setup, yes, you're physically connected to the throttle body, and yes, 100% at the throttle means 100% at the engine. But remember what I said, the same parameters here that are checked by the PCM are also the same parameters here checked by the PCM, only that in this case, the TPS is giving the engine the feedback it needs with regards to what your throttle position is at. But it will not always allow all those changes to be affected until some of these variables are considered. So now that we have a little know-how about how all these work, why don't we see why the maths are such a problem? And I'd just like to bring it up that this will primarily affect the number one guys, the ones with the ceiling mounted or the roof mounted throttle. The number two guys, the floor mounted throttle, are not really affected, but still, it's good manners to know that your throttle is not impeded. So we shall again have our throttle set up, whereby we have our throttle pedal assembly hanging from the roof. And the only difference now is that we have a mat in the way. So your nice thick mat is seated there between the throttle and the floor. So just out of visual reference, it is very easy to see that with the mat in the way, you will only have a certain percentage of travel, pedal travel, compared to when the mat is not in the way and you have your full travel of the pedal. This is why we were seeing those values with the diagnostics. When the mat is in the way, you can get anywhere from only 40% to maybe 60% with the mat, while without the mat, you would see anywhere up to 80% plus. Now, this brings up another interesting conversation, and it is more or less an industry standard. But manufacturers have been forced to comply with certain regulations, and let's just call it the throttle tree, or the throttle plate tree, if I may use that. What that means is you have an upper limit and a lower limit whenever you're talking about throttle percentages, and this mostly affects fly by wire. Reason being, as you saw in some of the previous instances, it wasn't a perfect 0% to 100% reading. There were some variances, and so the industry standard makes it mandatory to have some sort of fluctuation on the throttle body readings or throttle pedal readings. And for most cars, they will start at anywhere from 5%, if I'm not wrong, to 12%. Anything below this is considered closed throttle. And anything for most other cars, anything above, I believe, 80% to 85% is considered wide open throttle. Why is this, you might ask? There are certain instances, and the mat is one of them, that have been factored into these fly-by-wire configurations. And so it's not a perfect science, but it makes it almost perfect in the sense that you have a very good close ratio of how the powertrain computer or how the engine computer sees your throttle pedal inputs. So you're allowed to have anything in this range, anything from 12% and up being considered, 12% to about 80% being considered partial throttle. So in between this range, the engine computer will just figure out, based on these other parameters we talked about, the intake temps, the coolant temps and whatnot, it'll try figure out how much you need, how much power you need, and then of course give you the basic output. That said, I know it's a lot of science and math, but I believe the diagrams explain themselves. So what can we do about it? What can you do about it to keep safe and operate your vehicle optimally? A couple of things. One is you can choose to use the right mat. Just, use the factory mat and just figure out how you will get to be cleaning it every so often, right? Secondly, if you must use an aftermarket mat that's either rubber or plastic, then let's take an example of this as being our factory mat. And you saw them. They were very clearly outlined in the shape, leaving enough room for our throttle pedal. So let's just use that as our throttle pedal. You can, with your factory mat, assuming the red is a factory mat, overlay it on your factory mat. The red is the aftermarket mat, so overlay the aftermarket mat on the factory mat, and then mark out the points at which it intersects with the factory mat, and then cut out whatever is excess. Like I showed you, there's also an anchor point on these mats, either 1 or 2 points. Punch these out as well, and then use the aftermarket mat to sit in these anchor points so that it doesn't slide forward, because the problem is also that it can be a good fitting mat, but with time as you drive it keeps sliding forward and it'll still end up going under your pedal. So cut the chunks out and fit it as best as you can and make sure it's anchored. This leaves you with the dilemma of either having 2 mats or having 1 mat in use. So it's up to you. If it's a thick mat, you may want to use just the aftermarket mat. If it's a relatively thin mat, you can use both of them so that you don't lose the factory mat. So yes, that is why this is a silent killer, and that is why you should take keen note in knowing how the throttle works and what the aftermarket mats does to it, and also whether or not you are type 1 or type 2 throttle. Most of the type 2 throttles are unaffected by this, but still it's an impediment to the throttle movement. And you may also want to check whether your vehicle is a fly-by-wire or a fly-by-cable. But if it's anything manufactured after 2004, it's most likely a fly-by-wire, because it was more or less a standard issue back then. So be safe, check your mats, make sure that your vehicle is happy so that you are not in danger of risking your safety and those of your occupants. On that bombshell, I'd like to thank you for taking your time to watch this and get bored by all my math. 15 minutes of your life has just gone away, but I hope that you're much, much, much more informed. Subscribe, tell your friends. Have a good day.